Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at an example of hypothesis testing in which we are going to state a null hypothesis, making a claim. We're going to be using method 1. That's what my students in their classes are using right now. I'll do another video later on illustrating method 2. But the null hypothesis says the mean equals a number in method 1. And then the research hypothesis, H sub 1, is what some textbooks also use. We're going to say either greater than, less than, or not equal to based on the question that's posed. And then from there we can reject or accept depending on whether we're using z-scores or t-scores. If the standard deviation is known, then we use a z-score. That's of the population. If the standard deviation is known, if it's unknown, then we use a t-score. Alright, so let's look at this wonderfully long example. I decide to quit teaching and sell a new type of battery. I make a claim that it lasts an average of 500 hours before it goes out. The variance is 25, so out of all that information, that's the two important things, and its distribution is normal. Duracell and Energizer, Hayton, they say, oh, okay, there's no way that it could last that long. And they test 100 of my batteries, come up with a mean of that, and a variance of that mean of that. And then I want to know if there's enough evidence to refute my claim. Basically, tell me I'm full of crap about my 500-hour batteries. All right, so let's write some stuff down. The population is normally distributed with a mean of that and a variance, I believe, was 25. Yes. So the standard deviation is the square root of that, and that would be that one there. Then we have a sample that has 100 batteries in it, and mu sub x bar, or x bar, whatever you want to call it, was 498. And it had a standard error on its standard deviation on that mean of 36. Alright, so that's basically everything that we need. So what we do is we look for the z-score first. Z is going to equal to mu sub x bar, or x bar, whatever your book uses, over sigma sub m, or sigma sub m just equals that. I don't like to mess things up. I just go ahead and plug in. So we have 498 minus 500. Now, which sigma do we use? Do we use the sigma of the population, the standard deviation of the population, or of the mean? Well, if you know the one of the population, always use the one of the population. Okay, so it's going to be over 5 divided by the square root of 100, right? So that's going to be 5 over 10, which is 1/2. So we have negative 2 over 1/2. And you multiply, and you get a negative 4.0. Okay, so if you remember, the z-score is a way of divvying up your normal distribution. And it's basically looking at the number of standard deviations we are away from this middle, and the middle being 0 z-score. We have all the way to roughly 3.5 on the top end and negative 3.5 on the bottom end. And I give you a significance level of 5%, which means that p-value of the bottom half. Why is it the bottom half? Oh, I never stated my claims, did I? Or my hypotheses. So let's do that real quick. My null hypothesis was mu equaled 500. Sorry. And then my research is that mu is less than 500, right? Because that's what Energizer and Duracell are claiming. And then they came over here and tested it, and they found that I was indeed way over here in negative 4, which is somewhere like at the very tail end. So with these specific 100 batteries, if you were to go on your z-score chart, you wouldn't even find a p-value associated with that z-score. So you would say yes in this case. Yes, there is enough evidence to reject the null. Basically to say that my claim is false. So in other words, to say the batteries last less than 500 hours. Okay, so when we're doing this, if you remember, our z-score here that we tested out was a negative 4.0, and we could compare z-scores, right? So if I looked up the z-score for 0.05, I think it's 2.9, something. It's roughly in the 2s, and our z-score that we calculated is negative 4, so which is way less. You could have also converted this z-score into a p-value by looking up the z-score on the top and the bottom, right, of your z-score chart, finding the p-value inside with all the numbers, and then comparing that to 0.05. And if that was less than 0.05, which it'll be, because again the chart only goes to negative 3.5, then you reject either way, whether you compared p-values or z-scores. If I were you, I would just use both methods and try to see which one you like best and stick with that method. Alright? So make sure you check out the other 2 example videos in which we're going to do a rebuttal, in which my battery company is going to do another study saying that, you know, those batteries, 100 batteries that Duracell and Energizer test must have been tampered with, because my batteries are way better than just a mere 500 hours. Alright, so then we might even take it to court and have a third party, neutral party, test to see which one of us is correct, and then just apply that to our statistical means of inference that we're using here for hypothesis testing. Okay, so check out the other example videos. Practice, practice, practice. Thank you, and have a nice day.